So pH, we are familiar with referring to hydrogen ion concentration. It can also be defined with respect to other ions. The most common is the hydroxide ion, and so we can say that POH is the negative log of the hydroxide ion concentration. So we use P as a mathematical operator, and it stands for the negative log, meaning the base 10 logarithm of this changed the sign, okay? So we can also look at pKa, where Ka is that acid dissociation constant. So pKa is equal to negative log of Ka. Okay, so there are relationships between pH, POH, hydroxide ion concentration, and hydronium ion concentrations. And so I'm going to derive the relationship between pH and POH. You do not need to know how to do this, but it's kind of cool. So what are the things we know? Well, we know the definition of pH, right? pH is the negative log of the hydronium ion concentration. And POH is the negative log of the hydroxide ion concentration. What's the relationship between hydroxide and hydronium ion concentration? 10 to the minus 14. Right, so Kw is equal to 1.0 times 10 to the minus 14, and that's equal to the hydronium ion concentration times the hydroxide ion concentration. Okay, so those are all things that we've talked about. So this equation here is giving us a relationship between these two ions. So we could take this equation here and take the base 10 logarithm of both sides. You might think, why do we want to do that? But, it's what we're going to do. So I'm going to take the negative log of 1.0 times 10 to the minus 14. And that's going to equal, I didn't leave myself much space here. I'm going to move this, because I can. When I take the logarithm of things that are multiplied, then I've got the logarithm of each of them and those terms added together. So this will be the negative log of hydronium ion concentration plus the negative log of the hydroxide ion concentration. So what's the negative log of 10 to the minus 14? 14, right? The log of 10 to the minus 14 is minus 14, and we change the sign and we get 14. So that side is equal to 14. What's a more convenient name for that term? pH? So 14 is equal to pH plus POH. So the relationship between these two P units, pH and POH, is actually very simple. They add up to equal 14. Any questions? So you don't need to know how to do that, but you should remember that POH plus pH equals 14. So the circle of pH. So we've got 4 different quantities, and they are related to each other, and I think of them as being in a big circle. I call it the circle of pH, and then you hear the Lion King theme song playing in your head, right? So it doesn't really matter where you put them or what you start with. I'm going to start with pH at the top, and then we'll put POH over here, and hydroxide ion concentration down here, and hydronium ion concentration over here. We can convert between pH and POH. We can convert between pH and hydronium ion concentration. We can convert between hydronium and hydroxide, and between hydroxide and POH. I don't know of a relationship going directly from pH to hydroxide ion concentration. You could find one, but it's a lot simpler to just go through POH or go through hydronium ion concentration. If you're starting with hydronium ion concentration and you want the pH, you could go to hydroxide and POH and then to pH, but that's longer, right? So I like this circle because you see where you are, where you need to go, choose the shortest route or choose the route that seems easiest to you. So then I'm going to put the relationships in here. For this conversion, we have pH plus POH equals 14. Down here, let's start that over. POH is negative log the hydroxide ion concentration. We're going the other way. Hydroxide ion concentration equals 10 to the negative POH. Over here we've got hydronium times hydroxide means 1 times 10 to the minus 14. And then up here, pH equals negative log of hydronium ion concentration, or hydronium ion concentration equals 10 to the negative pH. And that's the circle of pH. Those are relationships that you should memorize, that you should be able to remember. They're not as bad as like the Arrhenius equation or stuff like that. And we use these a lot. So any questions?